Okay, grade 8. This is chapter 10, lesson 4. It is the same as term 2, lesson 2, geometric proof and column. That was in chapter 8, chapter 5. See this lesson here? The one we did like this, with 2 column proofs, this lesson. Okay? That's what we are going to do here, but use different properties, okay? And you should remember your addition property of equality, your subtraction property of equality, your multiplication property of equality, and your division property of equality, because you're going to use them here in this lesson. Okay? All right. So, proving theorems about line segments. Here we were doing geometric proofs, yes? Using angles. That's what we were doing in this lesson. Now here, we are going to do line segments. You will write proofs involving segments. You will write proofs involving segment congruency. That means why segments are equal or same measure. Now, the first one is called the ruler postulate. What does this mean? When one end of a line segment, on a line segment, you have 2 endpoints, yes? You have a point here and a point here. And then you take a ruler. Where is mine? I don't know where my ruler is. Oh, here. You take a ruler and you put one endpoint on 0. So that is the ruler postulate. You put one endpoint on 0 so that you find out where the other, and you make sure your ruler is flat. So one end will be on 0. It doesn't matter which end. So that you find out where the other point ends at on the ruler. So I might say mine is 3.5 centimeter or 3.5 centimeter. So you can use the 0 from the left, which is always good, or you can measure like that. You can put your ruler upside down and put 0 on one end and you measure. You will still get the same measurement. So that is what we are calling, what? The ruler postulate. Okay? So we line one endpoint of a line segment to 0 on the ruler and find out where the other endpoint will be on the ruler. Okay? And because you're using a ruler, all your answers must be positive real numbers. That means there can be a decimal, there can be a fraction, there can be a positive integer. Okay? Or a whole number. There you go. Then you have segment addition postulate. Now, when you have a segment addition postulate, you must have 3 points on one line. You have 3 points that are collinear. That means 3 points on one line. You have 1 point that is in between the other 2 points. The point that is in between C and E is D. So we say C, D, and E are collinear because they are on the same line. D is between C and E only if, the only time you will say D is between C and E is only if CD, this distance, plus this distance DE gives you the whole distance from C to E. So that is why I wrote if the whole line is equal to part 1 plus part 2. So this is part 1 and this is part 2. And from C to E is the whole. Are we together? You have to make sure you can only use this one when you can make this sentence. If this sentence is not true, then you cannot do that. Okay? Now we do the third one. Segment congruence. Segment congruence. Give me 1 second. segment congruence is when you have, there are three of them. There are three types of them. So you have reflexive property of congruence, and you have symmetric property of congruence, and you have transitive property of congruence. Okay? Now, let me explain reflexive property of congruence. Reflexive property of congruence is like me saying the distance from the beginning of my pen to the end is the same from the tip to the back. Or when I measure my height, from the head to the toe will be the same distance from the toe to the head. So, here, reflexive property, the line AB will be the same whether I go this way or I go back this way. Okay? Same. That is what we are calling reflexive property. So we will say a line segment is congruent to itself. A line segment